Force and pressure. Motion. Motion as a change in position of an object with respect to time. When we look around, we see many stationary and moving objects. Example, buildings, trees, electric poles, etc. are considered to be at rest, while moving cars, flying birds, etc. are considered to be in motion. But what do we really mean when we say that an object is either at rest or in motion? We can say that a body is at rest if it does not change its position with respect to time and its surroundings. For example, a standing tree remains fixed in its place if you see it at different time intervals. So, it is said to be in a state of rest. On the other hand, if an object changes its position with respect to time and its surroundings, it is said to be in motion. For example, if we stand on a road and observe a moving car, we find that its position is continuously changing with respect to us and different time intervals. So, the car is in motion. Activity. Throw a ball downward from the roof of your house. You will see that it reaches the ground. We can say that the ball is in motion because it changes its position with respect to you and the rooftop. Scientist. Born in Germany, Albert Einstein, 1879 to 1955, was one of the greatest scientists of all time. He developed the theory of relativity. He became the professor of physics at the University of Berlin and received the Nobel Prize for Physics in 1921. Einstein left Germany in 1933 and settled in the United States. He developed the special and the general theory of relativity. Rest and motion, relative terms. Let us consider a situation. Suppose you are traveling in a train with one of your friends. So, with respect to your friend who is sitting beside you, you are at rest. But when you look outside, you are constantly changing your position with respect to platforms, trees, electric poles, etc. So, simultaneously, you are both at rest and also in motion. Again, when we say that a body is at rest, first we consider that the earth is at rest. But actually, the earth itself is in constant rotation on its own axis. So, everything on the earth is also in motion. Thus, we can say that there is no absolute rest or motion. Both rest and motion are relative terms. One body which is at rest with respect to a particular reference frame may be in motion with respect to another reference frame. Types of motion. Objects move in different ways. For example, a car moves in a straight line, a fan rotates at its place, and the earth revolves around the sun. Therefore, the motion can be classified into these categories. Translatory motion. When an object moves in such a way that every point of the object moves through the same distance in same time, then motion of the object is said to be translatory motion. Example, a car moving along a straight road. There are two types of translatory motions. One, rectilinear motion. When an object moves in a straight line, its motion is called rectilinear motion. Examples: 1. A stone falling downward from the rooftop, a bicycle moving on a straight road. 2. A batsman taking a run between the wickets. 3. A group of ants moving in a line. 2. Curvilinear motion. If an object moves in a circular path or a curved path, it is called curvilinear motion. Examples: a car moving along a circular path, the motion of a javelin or a shot put thrown by an athlete. circulatory motion. When an object moves in a circular manner with respect to its own axis or around a fixed center, it is said to be in a circulatory motion. In these motions, the objects remain at the same distance from a fixed point, center. Circular motion is of two types: rotatory motion and revolution. Rotatory motion. If a body moves around a fixed point or axis, called axis of rotation, without changing its position, then its motion is called rotatory motion. Let us consider the motion of the blades of a fan. Point P is nearer to the axis of rotation. It covers less distance than the point Q, which is at a greater distance from O in the same interval of time. Examples: spinning top, moving fan, spinning potter's wheel. In rotatory motion, different parts of an object move through different distances during the same time. Revolution. When an object moves as a whole around a fixed center, it is said to be revolving. Examples: 1. Earth revolving around the sun in a definite orbit. 2. Toy train moving on a circular path. Activity: revolution of a stone. Take a piece of thread and tie a stone at its one end. Whirl it around your hand. The stone moves in a circular path. The distance of stone from your hand remains the same. The stone revolves around your body in a circular motion. Oscillatory motion. The complete to and fro motion of a body about its mean position is called oscillatory motion. In oscillatory motion, the object repeats its motion about the mean position after a regular interval of time. Examples: motion of pendulum of a clock, motion of a swing, motion of piston of a moving engine. Repetitive motion. When an object undergoes to and fro motion in such a way that some parts of it execute to and fro motion while the other parts do not, then its motion is called repetitive motion. Example: motion when the strings of a guitar are plucked. Activity: take a thin metallic wire. Tie it in a stretched position between 2 points tightly. Pluck it from the center. You will notice that it shows a to and fro motion, which is also called repetitive motion. Periodic motion. When motion of an object is repeated after a fixed interval of time, it is called periodic motion. The motion of the Earth around the Sun is repeated after 365 days. Thus, the Earth completes its motion around the Sun in a fixed interval of time, which is 365 days. Hence, it is an example of periodic motion. Examples: swinging of the pendulum of a clock, the motion of the needle of a sewing machine. Periodic motion is used for measuring time. Example: the pendulum of a clock completes one oscillation in 1 second. When 60 oscillations take place, the time moves by 1 minute. Non-periodic motion. When an object does not repeat its motion after a fixed interval of time while moving, its motion is called non-periodic motion. Examples: speed of a running boy, swinging of tree branches, etc. Random motion. If a body frequently changes its direction of motion in an irregular manner while moving, its motion is called random motion. Examples: motion of a mosquito in flight, motion of smoke particles in air, etc. Multiple motion. When an object possesses two or more types of motions at the same time, it is called multiple motions. Examples: when a spin bowler delivers a ball, the ball has a motion of spin, rotatory motion, while it moves towards the batsman, Translatory motion. The Earth rotates about its axis, rotatory motion, and at the same time, it revolves around the Sun in a curved path, curvilinear motion, in a fixed time interval, periodic motion. A drill machine has both translatory and rotatory motions. This is because while it is being rotated, rotatory motion, it is also getting pushed forward, translatory motion. Uniform and non-uniform motion. 1. Uniform motion. When an object moves in such a way that it covers equal distance in equal interval of time, it is called a uniform motion. During uniform motion, the body moves with constant speed throughout its journey. Example, a car moves a distance of 10 meters in each second. 2. Non-uniform motion. If an object does not cover equal distance in equal interval of time, it is called non-uniform motion. If the body covers equal distances in equal interval of time, but the direction of motion keeps on changing, then also the body is said to have non-uniform motion. Example, 1. The motion of a car moving on a busy road. 2. Motion of a freely falling body is also an example of non-uniform motion. Distance. The length of the path travelled by a body in a certain interval of time is called distance. Example, suppose a person has to reach from point A to C and he goes through point B. Then the total path covered is given by AB plus BC is equal to distance. It is a scalar quantity because it has magnitude only and no particular direction. Its units are centimeter in CGS and meter in SI. Displacement. The length of the path travelled by a body in a certain interval of time in a specific direction is called displacement. Example, in figure, the person moves from point A to C. The displacement is AC is equal to shortest length between A and C. It is the shortest length between the initial and the final position of the body. It is a vector quantity because it has both magnitude and direction. Its units are centimeter in CGS and meter in SI. Explanation. It may happen that displacement of a body is zero through the distance travelled is not zero. Let us consider a body thrown vertically upwards. The body reaches a certain height, h, momentarily, comes at rest and then again comes back to the thrower. So, the total distance travelled is h plus h is equal to 2h. But the displacement is zero as the initial and final position of the body coincide. We can differentiate between distance and displacement as given below. Distance, displacement. 1. The length of the path travelled by a body is called distance. The shortest length between the initial and the final position of the body is called displacement. 2. It is a scalar quantity. It is a vector quantity. 3. Distance covered by a body is always positive. Displacement of a body may be positive, negative, or even zero. Speed. Speed is a physical quantity which tells us how fast or slow an object is moving. Example, a car moves faster while a cycle moves slower. Speed of an object is defined as the distance covered by an object per unit time. Speed, s, is equal to distance, d, upon time, t. Speed is a scalar quantity. Do you know? The average speed of a turtle is 0.044 meter per second. Unit of speed. The SI unit, distance, is measured in meters and time in seconds. Unit of speed is equal to meter per second. A larger unit of speed is kilometer per hour. Example, suppose a car travels a distance of 50 km in 2 hours, then the speed of the car is given by speed is equal to 50 divided by 2 km per hour is equal to 25 km per hour. Fact: light travels very fast. Even then, it takes nearly 8.5 minutes to reach the Earth from the Sun. Velocity. The velocity of an object is defined as the distance covered by an object per unit time in a given direction, or velocity of a body is the displacement produced per unit time. That is, velocity is equal to displacement upon time. Its SI unit is meter per second, or velocity is a vector quantity. Along a circular path, speed of a body remains the same, but velocity changes. Speed is the distance covered per unit time, while velocity is the distance covered per unit time in a specific direction. In the figure, it is shown that a stone tied to a string is moving in a circle of radius equal to the length of the string. At each point of the circle, the speed of the stone is same, but its direction is different, hence its velocity is different. This is because a change in direction also changes the velocity, though the speed at which a body moves may remain the same. A body is said to have constant velocity if its speed as well as direction of motion do not change with time. Average speed and average velocity. Average speed is equal to total distance travelled divided by total time taken. Average velocity is equal to total displacement divided by total time taken. Explanation. The average velocity of a body can be zero, even though average speed is not zero. When a body moves along a circular path and comes back to the same initial position after a certain time, its displacement is zero. So, its average velocity is also zero. But the total distance travelled is equal to the circumference of the circular path. Hence, the distance travelled is not zero, and therefore the speed is also not zero. Activity. To show the motion of a ball on an inclined plane. The direction of motion of a ball on an inclined plane does not change, but it covers unequal distance in equal interval of time. Weight. Often we use the terms mass and weight in the same sense, but actually they are two completely different physical quantities. The force with which the earth attracts a body towards its center is called weight. This force is also called the force of gravity. This force always acts on a body downward towards the earth. It is maximum on the surface of the earth. It varies with respect to the height and depth from its surface. As a result, the weight of an object starts decreasing as it moves higher above or deeper below the Earth's surface. Even on the Earth's surface, the weight of the object may vary from place to place. Its value is minimum at the poles and maximum at places lying on the equator. The weight of a body depends on the following factors. 1. Mass m of the body. 2. Acceleration due to gravity g. The weight w can be expressed as w is equal to m into g. As the value of acceleration varies from place to place due to gravity, the weight of a body also differs. Weight is a vector quantity having magnitude as well as direction. Whatever be the weight of a body on the surface of the earth, its weight becomes zero when it is taken to the center of the earth. Unit of weight. The SI unit of weight is Newton, N. The subunit of weight is dyne. The weight of an object is also measured in kilogram force or gram force. 1 kilogram force is equal to 9.8 Newton. 10 Newton. We can say that weight of a body of mass 1 kilogram is either 1 kilogram force or 10 Newton. Measurement of weight. Weight can be measured by using a device called spring balance because the extension in the spring depends on the force with which it is pulled downward by the earth. Thus, it is the gravitational force acting on the object which operates as spring balance and not its mass. Let us discuss about it in detail. Spring balance. It is an instrument used to measure the weight of a body. A pointer and a long rod ending in hook is attached to its lower end. The spring is enclosed in a metallic case, so that pointer moves on a scale fixed to it, and the hook hangs out of the load. At the top of the case, a metallic hook is attached to hang the balance. A spring balance works on these principles. The extension produced in a spring is directly proportional to the weight suspended from the spring. That is, if the weight of a body is more, the extension produced in the spring will also be more. In other words, the pointer will move downwards to a greater extent. For the laboratory, small spring balances are used, and for other purposes, large balances are used. Activity. To show that different weights exert different forces on the same spring. Take 3 springs of the same stiffness, that is, all 3 will show same extension when same force is applied. Suspend different weights, for example, 5 gram, 10 gram and 15 gram on the springs. You will notice that all the springs will show different extensions. This shows that different weights will exert different forces on the same spring and hence different extension is observed. Differences between mass and weight. Mass, weight. 1. Mass is the quantity of matter possessed by a substance. Weight is the force by which the earth attracts a body towards it. 2. A beam balance or a physical balance is used to measure the mass of an object. A spring balance is used to measure the weight of an object. 3. Mass of an object is constant. Weight of an object changes from place to place. 4. It is a scalar quantity. It is a vector quantity. 5. It is measured in kilograms and grams. It is measured in Newton and kilogram force. The physical quantity which has magnitude only is called a scalar quantity, while the quantity which has both magnitude and direction is called vector quantity. Do you know? The weight of an object on the moon is 1/6 of its weight on the earth. Do you know? A spring gauge balance is a simple force measuring device. Measurement of weight. Weight can be measured by using a device called spring balance because the extension in the spring depends on the force with which it is pulled downward by the earth. Thus, it is the gravitational force acting on the object which operates as spring balance and not its mass. Let us discuss about it in detail. Spring balance. It is an instrument used to measure the weight of a body. A pointer and a long rod ending in hook is attached to its lower end. The spring is enclosed in a metallic case, so that pointer moves on a scale fixed to it, and the hook hangs out of the load. At the top of the case, a metallic hook is attached to hang the balance. A spring balance works on the following principle. The extension produced in a spring is directly proportional to the weight suspended from the spring. That is, if the weight of a body is more, the extension produced in the spring will also be more. In other words, the pointer will move downwards to a greater extent. For the laboratory, small spring balances are used, and for other purposes, large balances are used. Activity. to show that different weights exert different forces on the same spring. Take 3 springs of the same stiffness, that is, all 3 will show same extension when same force is applied. Suspend different weights, for example, 5 gram, 10 gram and 15 gram on the springs. You will notice that all the springs will show different extensions. This shows that different weights will exert different forces on the same spring and hence different extension is observed. Differences between weight and mass. Mass, weight. 1. Mass is the quantity of matter possessed by a substance. Weight is the force by which the earth attracts the body towards it. 2. A beam balance or a physical balance is used to measure the mass of an object. A spring balance is used to measure the weight of an object. 3. Mass of an object is constant. Weight of an object changes from place to place. 4. It is a scalar quantity. It is a vector quantity. 5. It is measured in kilograms and grams. It is measured in Newton and kilogram force. The physical quantity which has magnitude only is called a scalar quantity, while the quantity which has both magnitude and direction is called vector quantity. Do you know? The weight of an object on the moon is 1/6 of its weight on the earth. Do you know? A spring gauge balance is a simple force measuring device.